excited to have you and so excited to welcome you to the Great Space Escape. My name is Talia. I'm the Virtual Experiences Coordinator at the Denver Museum of Nature and Science, and I'm joined this evening by two of our space science experts, Naomi Piquet and Jose Zuniga. They are awesome. We love them so much. They do such an incredible job. They know way more about space than I could ever even hope to. And so you are in for a real treat this evening. And again, we just want to say a big thank you to all of you for your support of the museum, and thank you for being part of our community members. This program is being presented live exclusively for you. Again, thank you for your support. Before we begin, just a couple of quick housekeeping items to get going. You might have heard me say already that you are welcome to communicate with us via the chat this evening. And if you haven't already done so, take a moment to type in the chat, say hello, let us know where you're watching from this evening, how many people you have with you, and their ages or grades. The reason we ask about ages is that this program does carry a PG-13 rating. Greco-Roman mythology can get a little bit saucy, if you know what I mean, and we're going there this evening. We're going to get a little wild. We're going to tell some stories. So just keep that in mind. We, of course, trust you to make that decision for yourself. Thanks again for joining. A quick note about the chat is that it is set to only send your messages to us. So we, as staff of the museum, are the ones that will see your comments and will see your questions. We are watching that chat throughout the entire program, and we will pull your questions to ask Jose and Naomi. So again, make them good ones. We really want to test their knowledge. And we do, of course, thank everyone who has already submitted some fantastic space jokes. I'm going to have to up my game. That was pretty good. We got a good crowd this evening, everyone. Thanks for joining in. Without any further ado, I'm going to hand it over. Jose and Naomi, take it away.
All right. Welcome to the Great Space Escape. Over the next hour, we're going to have some fun. We're going to learn some stuff. We're going to tell some jokes. My name's Jose, like I said, science educator at the Denver Museum of Nature and Science. Take it away, Naomi.
And my name's Naomi. I'm going to be your pilot for the evening, controlling this really cool piece of software called UniView that normally we use to control our planetarium. I'm a space scientist and an educator at the museum. One quick housekeeping thing. I'll channel my inner Talia, our Uhura, for the evening, and say, this is a really graphic heavy program. I had to go get a very specific computer to be able to run this for you tonight. And so for the best experience for you, please turn off everything else you're running on your computer except for Zoom, and that will make your experience the best you possibly can. And the good news is it's a flat screen. There's no way I can make you sick with my piloting tonight. So this is really a so much easier job for me tonight. I feel like I'm getting off easy.
Yeah. Naomi and I usually do this program in the planetarium, and we're actually using the same software that we use in the planetarium here on the computer, so that's pretty cool. The beginning of every Great Space Escape begins with a series of stories related to constellations that you can see this evening, especially if you are in Colorado and the Denver metro area. So right now it's just a little after 8 o'clock. And so this is sort of, this little circle you see here on the screen is what the night sky sort of looks like right now. And we're going to talk about some constellations that once we're done with this program at 9, you can step right outside and see. It might be a little cloudy. I know we're expecting some bad weather, but if you get a chance, maybe you'll be able to see them. So we're going to start with our very first story, which is about two of the most famous constellations in the sky, the Big Dipper and the Little Dipper, which are actually supposed to be bears. Not dippers at all. Now the Big Dipper, like once you add the head and the legs and stuff, okay, I see. But the Little Dipper is always just looks like a dipper. It never looks like a bear. Also, why do they have long tails? Okay, well, we'll talk about why they have long tails. That's part of the story.
Spoiler alert.
What?
Spoiler alert.
Yeah, spoiler. Okay, so this is the story of Callisto and Zeus. Zeus is going to show up a lot in these stories, heads up. And Zeus is a piece of work. Yeah. There's Zeus right there. Or some romanticized statue version of him. He's just hanging out with a little cloth on and got some thunder in his hand, looking serious. That's very Instagram kind of pose. I feel like he's like, what's up? Just hanging out, Zeus. And
I feel like that's more like his Tinder profile pic. I just gotta throw that out there.
Listen, yeah, Tinder, that's a little too tame for Zeus. I think he looks for something a little bit more risque. And speaking of Zeus and being risque, this story is all about him and this lady Callisto. So Callisto was the daughter of the king of Arcadia, and she decided she wanted to be dedicated to the goddess Artemis. And the famous thing about Artemis, she's Apollo's twin sister, goddess of the hunt, and she was a virgin. Sex and her, that was a big no-no. So if you were going to be an attendant of Artemis, if you are going to serve her, then no sex for you either. You had to be a virgin. So she took a vow of chastity. She was chaste. Okay, fun little side note. So sometimes at the museum we get these exhibits where we portray hysterical and historical characters. And we did one on Pompeii, and one of our characters was a Vestal Virgin. This woman, I've known her for a long time. She was she's in her she was an older woman, let's just say it that way, and she was portraying a Vestal Virgin, and she was talking to a group of like 12-year-old boys, and she was trying to explain her why, like what the requirements of being a servant of Vesta was. And she said, well, I got to keep the fire burning, I got to lead the sacrifices, and then I have to be chaste. And one of the boys like raised his hand and said, who chases you? Oh, it was great. It was great. Anyway, that's a little side note. So Callisto went into the service of Artemis, and she was a virgin. Well, one day Zeus was looking down from Mount Olympus, and he saw Callisto, and he was like, oh man, she is so beautiful. I am definitely about that. But the attendants of Artemis were guarded by her nymphs, and also Callisto didn't, she was devoted to Artemis, didn't want to have anything to do with Zeus. So he was like, well, I'm gonna make it happen. So doing like he does, Zeus, he transforms himself into Artemis. He makes himself look like Artemis, and he comes down to Callisto, and he's like, hey, Callisto, it's me, Artemis. And she's like, oh, hey, Artemis, what's up? And then Zeus/Artemis is like, I think you are so incredibly beautiful. One thing leads to another, and then I'm sure to Callisto's great surprise, she ended up pregnant. So I always love these little like paintings that we find. One thing is there's always some sort of red cloth in it somewhere. If you find, I don't know why there is, but there's a red cloth in all these paintings. And also, I feel bad for those cherubs, they're about to get an eyeful of something maybe they don't want to see. Anyway, so Callisto is very surprised to find out that after she slept with Artemis, she actually is pregnant. And so she goes to Artemis and tells her, what's the deal, what's going on? And eventually the truth comes out that it wasn't Artemis, that it was Zeus in disguise. So Artemis is furious with Callisto because that's a reasonable reaction to her getting her identity stolen and having it be used to seduce one of her servants. And then Zeus's wife Hera also gets super mad at Callisto. So after Callisto gives birth to her son Arcas, she transforms Callisto into a bear. That's a lovely picture of Artemis throwing Callisto out of her garden. Because, yeah, that's fun. There's that swoopy cloth. There's always swoopy cloths. Like when that's just going right over her head. What's the deal with that? I don't know. It distracts me every time. But so Artemis is now a bear. She's a bear. She's wandering around in the wilderness and, doing her bear thing. Her son Arcas grows up, and since he's a demigod, he's good at doing a lot of things like running and jumping and climbing trees. And he's also really good at hunting. So he becomes known as this really sort of famous hunter. And then one day he's in the woods and he sees this bear, and he decides that he's going to get that trophy. He's going to kill that bear. Look at this very sporting shot right here. He's like 2 feet from that bear, which is like half a foot tall. Just gonna like take it out.
The myth says it's the largest bear in the forest. I'm thinking I'm not so afraid of that forest right now.
Yeah, how big are the other bears? If that's the largest bear in the forest, like what's the deal with that? Anyway, so Zeus, I don't know where he's been all this time. Arcas is grown up. Like, he's been a totally absent deadbeat dad. He totally let this woman get turned into a bear. He doesn't care at all about his son. But now, of all moments, when he sees that Arcas is about to kill his mother, who is a bear, and was transformed into one because it's his fault, Zeus was like, oh no, I should step in and use my godly powers to make this situation better. So he turns Arcas into a bear because that makes the most sense, I suppose. And then to keep them from Hera's wrath, he grabs them by the tail and throws them into the sky, which is why they have such long tails. Which is, look at this image right here. It's just so great. So that's why the Big and the Little Dipper have those long tails right there. They are supposed to be the big bear, the little bear, Callisto, and Arcus from this story. Now, there's a little addendum because in a lot of these stories, Hera gets the last word. And so Hera, upon learning that the bears were safely in the sky and that she couldn't get to them up there, she went to her uncle Oceanus? Uncle Oceanus, and says, "Hey, don't ever let them take a bath." And he's like, "No, okay." So these constellations, we call them circumpolar constellations. That means they're visible at all times of the year. The star at the end of the tail or the handle of the Little Dipper is actually the North Star. So these stars just sort of turn in a circle as night goes on. So if you want to see them tonight, you step outside and look toward the north. That's where you can always find the Big and the Little Dipper, or Callisto and Arcus. Poor victims of Zeus's needs. Let's just put it that way. All right. Moving on to our next constellation story. Let's see here. Which one did we have next?
Orion.
Orion, right, Orion. Okay.
And I feel like I should jump in a little bit with orientation, just so you know. Down is north and up is south. So that makes right east and left west, and you get to do a really weird dance with me apparently. But just to give you an idea of where to look in the night sky, since this is meant to be like our planetarium dome and be over you, it's a little hard to understand sometimes.
I will say the whole program won't be like this. Once we transition into the second part of the program, we'll get to see some really close-up visuals of planets and moons and stuff like that. So just bear with us for these constellation stories.
Haha, bear, like the last story, get it?
Oh!
I'm just popping in to say if anyone has any questions, we are also watching the chat for those. So if you do have any questions, go ahead and pop them in there. I will pitch them to our hosts when the time comes. And now I think we're going to hear a second constellation story.
All right, this constellation story is the story of Orion. Orion has lots of different stories about him. We picked one of the more coherent versions. Well, a lot of these myths are like, oh yeah, and then he went and climbed a mountain and something else happened and blah, 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 blah. So we try to pick sort of condensed versions. There's lots of different versions out there. Orion's probably also one of the most famous constellations, really recognizable. There's Orion right there. I don't think he probably ever looked like that. My guess is this fountain was made in the Renaissance. And he forces children, poor naked children, to hold him up. So that's a little cruel too, I think. Speaking of hunters, Orion was a really, really good hunter. He was strong. He was tall. He was good at running and jumping and climbing trees, very just like Argus. I mean, I'm seeing a trend here. There's lots of things about him. They say that he was actually born. They say that he was actually born when a bull hide, like the skin of a bull, was buried in the ground, and then three gods like urinated on it. So I don't know what kind of frat boy pranks those gods got up to, but apparently that gives you one of the greatest hunters that ever lived. Other things that Orion was supposed to be able to do is he was supposed to be able to wade through the ocean just like we would wade through like a pool. And he was so good looking that everybody who saw him was just like, oh, Orion, oh. But Orion was in love with only one woman, and that was a princess named Merope. Is it Merope or Merope, Naomi?
If you listen to Harry Potter movies, it's Merope. So I'm going to go with that because it's Tom Riddle's mother. And that's the reference I know.
Okay. Well, however you pronounce it, Orion went to her father, the king, and was like, hey, I want to get married to your daughter. And he was like, okay, but first you have to kill this beast that's been plaguing my kingdom. And so Orion was like, okay. And he basically like walked outside with his two dogs, killed the beast, came back like that afternoon. And the king was like, well, you can't marry my daughter yet. You've got to kill this other beast first. And he was like, oh, okay. So he goes off and he kills this like, oh, that's a great picture.
That's
more beasts to slay by royal decree, princess not included. Such a legally minded document, but I guess he is the king, you know. So Orion basically marches across the countryside, murdering poor innocent monster one after another, and it's hard to be a Greek monster. Like, if you're a Greek monster, sometimes you got like a snake for a tail and like a goat head and a lion head, and that's got to be tough. And so one of the things about it, after he kills half the countryside, I feel like Orion's just murdered everything. The king is running out of beasts for him to murder. He kills three-headed dogs. He murders all sorts of things. And so the king goes to Orion and says, "Oh, I've got one more creature. Just go up this mountain over here and wait, and the creature will be along shortly." So he actually sends a little scorpion. The king gets with the little scorpion monster, and the little scorpion monster goes and stings Orion, and Orion dies. He's a great, great, mighty hunter who can climb mountains and cross oceans and all that sort of stuff. And then he gets stung by a scorpion and dies. So anticlimactic, I think, is what they should call Orion's story. Hey, anticlimactic. And actually, Orion gets put into the sky by Zeus because he is such a great hunter, and Zeus wants to recognize his wonderful deeds. And the scorpion also gets put into the sky, and that's the constellation Scorpio. And one of the things you'll notice is that when Orion sets, Scorpio rises. They're never in the sky at the same time. Orion is always running away from Scorpio in the sky. He's always like, Scorpion's gonna chase me forever across the sky. That's my Orion impression.
But also he's like running after the sisters and the Pleiades, including the princess he's in love with for the rest of eternity. So he's in this really weird race for the rest of time because Zeus has a weird sense of humor.
That's right, because Zeus is Zeus. Zeus being Zeus. All right, we're going to move on to our third and final constellation story before we open it up for suggestions and questions that you folks have. And this is the last one is a constellation that's actually right next to Orion, and it looks like he's fighting this constellation actually in the night sky, and this is the constellation Taurus. Taurus the bull, which is one of the 12 zodiac signs. I see a question here that says, can you please tell me about the 13th sign, Ophiuchus? Ophiuchus is that Asclepius' son? Asclepius' son?
There's no clear mythology for Ophiuchus, which is why I never pull him into these. But he basically is like dipping his toe in the zodiac. His full body's not in the constellation, but like his foot is. So if you're born towards the end of November and you account for the precession of the Earth, like my father, you can tell everyone when they ask you what your sign is that you're an Ophiuchian.
Of the stories I've heard of him, he's usually associated with healing. He's holding a snake.
Yes.
And that Ophi in his name means snake, Ophiuchus. And the Greeks associated snakes and the shedding of their skin with healing and medicine, which is why Mercury, who is also associated with healing, or Hermes, his staff has wings and two snakes wound around it. You can see that on hospitals actually to this day, those snakes representing this concept of healing that came from that sort of Greco-Roman tradition. And I see a question here, no mention of Orion's belt. That's true. Orion's belt, most famous stars in Orion, those 3 stars. And scientists actually say that Orion's belt is a big waste of space. Okay, moving on to Taurus. Moving on to Taurus. So there's multiple stories associated with Taurus, but the story that we are going to tell is the story of Europa and Zeus. So Europa is another beautiful lady, and Zeus, he just sitting on Mount Olympus looking down and saying, there he is right there looking down, looking for beautiful people. And listen, Zeus's tastes were not just limited to beautiful women. He also shared his company, whether they wanted it or not, with several beautiful men. And also Ganymede, which is the name of the largest moon around Jupiter. Ganymede was a 12-year-old boy. So, way to go, Zeus. Just really setting the bar high there for good practice. So he looked down and he saw Europa. Europa was beautiful. She was the daughter of King Agenor, and she was one day strolling with her companions on the seashore. Now, Zeus wanted to get Europa all to himself, but she was surrounded by her entourage, and he didn't want to just swoop in and snatch her up. So instead, he appeared before them as a perfectly white bull, but instead of one that was frightening, it was gentle and loving. Here you can see that the Europa and her attendants decided to put garlands and flowers and things on the bowl and dance around with it, because that's a totally normal and reasonable reaction to a gigantic bowl just walking up to you on the beach, instead of like running away or something like that. And so Europa finally decides to climb up on top of the bowl, as you saw in that image right there, and that's the chance that Zeus was waiting for. As soon as Europa is on his back, the bull runs into the sea, and she is separated from all of her entourage. And he carries her off to an island, and I'll let you use your imaginations about what happens next. Yeah, and there's not really any specificity in the story that he transforms back into a human first, so that's rough.
I do
Rough
love this
stuff.
image though of the cherub there that's just like, yeah, I'm gonna lead this bull with some flowers, and the bull.
Yeah, right. And there's the billowy cloth again. I'm sure there's something like in art history and stuff that talks about why the billowy cloths are there. But yeah, just the billowy cloths. Always a billowy cloth. I see a question here. Have we ever made anybody vomit in the planetarium by moving the projection too quickly? No, but I myself personally have fallen over in there a couple times. I've gotten dizzy walking up and down those stairs and fallen over.
I was just popping in to say a big thanks for the questions. Jose, are you ready to take some?
I think so. We're going to transition to that second part of the program. Now, like I said, this evening, if you go out and you get a chance, if the weather's cooperating, and look to the north, you can see the Big Bear and the Little Bear, the Big Dipper and the Little Dipper. And if you look to the south, you can see Orion. And right next to Orion is Taurus. And then not too far away from Taurus, and actually to the west, right now I think it might be a little late. It might have set behind the mountains. But there is a planet that is very, very visible right now at this time of year. It is the planet Venus. You know you're looking at Venus because it will not twinkle. Planets don't twinkle. Stars twinkle. Planets don't. It'll be really bright, much brighter than any of the other surrounding stars. Venus is the brightest object in the night sky, second to the full moon. And another thing about Venus is that if it blinks green or red, that's actually an airplane. So that's something to keep in mind too, if you're not sure.
We did have one question before we move on to Venus about that North Star, about whether it really never sets or not. So that's a pretty easy demo we can do here in Uniview real quick. I'm going to let time move forward here. And this is what I don't do in the planetarium. So we're gonna actually let this just step forward a little bit here, but you can see how as we move forward in time, everything is rotating around that North Star, which is at the end of our Little Dipper. And then the sun rises.
And then the sun comes up.
There we go.
But yeah, it sort of turns in this little circle. Yeah. So you can also find your latitude if you find the North Star. If you find the North Star, make a fist and put the bottom of your fist on the horizon. And this fist is about 10 degrees. So you stack it like this and then do another one, another one, another one until the top of your fists hit the North Star. And then you count the number of times you do that. That'll tell you your latitude. So if you're at the equator, the North Star will be on the horizon. If you're at the North Pole, it'll be right over your head. Here in Denver, we're about 40 degrees north. So we make about 4 fists before we hit that North Star.
All right, so when we move on to our planets, I'm just going to call this out. There is something a little different we're going to do in here because I want to give you the best view possible. You're going to see some warping on your screen for a quick minute while I change our view from what it looks like in our planetarium to something more appropriate for our screens today. And there we go.
This is when the visuals are going to get real cool.
And we'll fly off to Venus.
So instead of looking at it in the night sky, we're actually going to fly close to Venus. And this is the really cool thing about this program, Uniview. It really allows us to take these close-up looks. Now, all the images in this program, Uniview, are based on scientific observations. They're either real pictures or they are based on scientific observations and computer generated images. So here we are looking at Venus. Venus is the second planet from the sun. It's slightly smaller than the Earth. I like to call it Earth's evil twin. And that's because where the Earth is a nice, comfortable planet with lots of liquid water, Venus is extremely hot. Actually, it's kind of like Phoenix, Arizona. It's about 900 degrees Fahrenheit all the time, like Phoenix, and the atmospheric pressure is so heavy that it would crush a submarine, also like Phoenix. So, you know. The atmosphere is about 92 times thicker than the Earth's, and it's made mostly of carbon dioxide. When we look at Venus here, we can see lots of clouds. There's lots of other things in Venus's atmosphere, like sulfur dioxide and things like that. Lots of other nasty things that end in oxide. And Naomi can actually show us what Venus looks like without clouds.
I believe I can.
Someone says, can confirm on Phoenix. Yep, see, I knew it. So this is a radar map of Venus. The clouds are too thick for us to take a picture of the surface. So beginning in the 90s, we sent some spacecraft to orbit the poles of Venus. And as the planet turned under it, they beamed these radar beams down through the clouds and were able to make a radar map of the surface of Venus. The dark areas that you see are relatively smooth, like think smooth plains. And then the light areas are rough mountainous areas. And it would all be rock. We have landed spacecraft on Venus. The Soviets did. And one of the spacecraft lived for 2 hours. So that's pretty good. That's good work. You didn't usually get that out of the Soviet Union, you know, but they got that part. And Venus really hot with that runaway greenhouse atmosphere effect.
If I may, I see a question from Jennifer who is wondering, so does Venus stink?
Does Venus stink? No. Well, I mean, I don't think we'd be able to smell it. We'd be squished if we went there.
So a moot point then.
The sulfur dioxide would be really caustic too. You definitely want to breathe it in. It rains sulfuric acid on Venus. So you definitely wouldn't want to, yeah. What would happen if you went to Venus? You'd be squished, you'd catch on fire. You know, it's hot enough to melt lead on the surface. And a lot of pressure there as well.
I see a couple of comments in defense of Phoenix now saying, hey, it so does not get above 200 degrees.
Okay, all right. I mean, it was all in good fun. I enjoy Phoenix. I have some family there. I definitely go in the wintertime. I guess we Coloradans just aren't up to snuff when it comes to that kind of heat. All right. Well, now is a wonderful time for the remainder of the program, the time we have left. We're going to open it up to you folks. What do you folks want to learn about in the universe? We can use this cool program to fly and look at planets and moons. If you have questions in the chat, we'll try to get to as many places as we can, but we do have a limited amount of time. So bear with us.
For now, while you are popping your questions or your suggestions of what we should see next into the chat, there are a few people who are curious about knowing a little bit more about some of these signs of the zodiac. And I don't know if we have time to tell all the constellation stories, but perhaps you can tell us a little bit more specifically about Aries, Sagittarius, and Scorpius, or Scorpio.
So Aries is a ram. The stories I've heard associated with Aries is the ram that created the golden fleece that Jason sails with the Argonauts to go get, sort of like a magic ram that can, I don't know, do magic stuff. So they take its skin off and put it in a tree. Sagittarius, that is usually the centaur Charon. And Charon, most centaurs were like these kind of sex-crazed wild beings that would abduct you. And do bad things with you, which kind of tweaks the ending of that Harry Potter book, if you think about it from that context. And that centaur, Chiron, that's his name, Chiron, he was noble. He trained a lot of heroes. He trained heroes. And then what was the other one? Aries, Sagittarius, and
We have gotten a lot of requests for a lot of the zodiac signs. I think Scorpio was one of them. And then I'm seeing comments for Capricorn, Cancer. Maybe you can just real quick run us through what all of those constellations represent.
All right, we'll start. We talked about Aries and Taurus. That's the beginning. After that is the twins, Gemini, Castor and Pollux. That's another Zeus being Zeus story. He takes the form of a swan and has fun with a lady named Leda. She gives birth to 4 eggs, and out of 2 of those eggs come Castor and Pollux. One was immortal, one was not. And so when one of them died, the other one couldn't be without the other, so they were put into the sky. That's the twins, Gemini. The 2 brightest stars in Gemini are called Castor and Pollux. Then after Gemini comes Cancer. That's my sign. And Cancer is the little Y you see over on the right side right there. Are you a Cancer too, Talia? Yeah. Cancer is a crab that gets stepped on by Hercules. So Hera, when Hercules is fighting the Nemean lion, Hera sends a crab to snip at his ankles, and he steps on it. So that's Cancer. The coat hanger right there, that's Leo. Leo is the Nemean lion. Its skin can't be pierced by any sort of weapon. It's one of the labors of Hercules to kill the Nemean lion. And then after he skins it with one of its own claws, he goes all Tiger King and wears the pelt around as armor. Next to that is Virgo. She's going down a slide next to the coat hanger right there. And you know, Virgo is associated with a few different figures, but one of the main figures Virgo is associated with is a Titan who didn't get involved in the war between the gods and the Titans, and actually ended up being the embodiment of justice. And so right next to her is Libra, the scales, which she would use in her justicey things. Ooh, Venus question. What is the standard atmospheric pressure on Venus? 92 times thicker than the Earth. How deep is this atmosphere? I'm not sure off the top of my head, Naomi. Do you know?
What was the question? Say one more time.
How thick is Venus's atmosphere?
That is a good question. It is much, much thicker than what we have on Earth. Let me see if I can get an exact number. My number recollection is not great. So let me see.
All right. While Naomi's looking that up, I'll keep going with constellations. Let's see, Virgo, Libra. Then we have Scorpio, the scorpion that killed Orion, that chases him across the sky. After Scorpio comes Sagittarius, right? Scorpio, Sagittarius, yes. Scorpio, Sagittarius. Sagittarius is that centaur who was the archer. After that comes Capricorn, I think. Yeah, Capricorn, Aquarius, Pisces. Capricorn is the sea goat. Apparently, he lives at the bottom of the sea and he knows everything. And he had his kids and told them about the world, but they wanted to learn about it. So they left the sea, but as soon as they left the sea, they became real goats and became real stupid. So he got real sad and had Zeus put him into the sky. Aquarius is Ganymede. Ganymede is the water bearer, that 12-year-old boy that gets kidnapped by Zeus to be his love slave and also serve him drinks for all eternity on Mount Olympus. So that is Aquarius. After flying around the world and having many misadventures, usually involving him trying to talk Zeus out of being Zeus, Zeus rewards him by giving him a cup so he can pour out water and make it rain. And he likes making people happy. And then after that is Pisces, the 2 fish. And the story that I know about Pisces is that one day Aphrodite and Eros, her son, were fleeing some lecherous beings, and they dove into a river and transformed themselves into fish. But Eros was always... It was a real short chain between Aphrodite and Eros. She really liked to keep a close eye on him. So she linked their tails with a ribbon so that they couldn't escape from each other. So those are a quick rundown of those sign constellations right there. But I see some things in the chat here. I was going to say,
I see a lot. Sorry to talk over you, Jose. I'm seeing a lot of comments in the chat about Saturn and Jupiter, and then also a lot of requests for some of the moons. So perhaps those can be some of our first destinations, Saturn, Jupiter, and some moons.
And I also see a lot of requests for Pluto and questions about Pluto's in the Q&A as well. So do we want to make a plan to do Jupiter,
Saturn, Pluto?
Let's do a moon in there and then Pluto.
Okay. How about Jupiter, Saturn, Titan, Pluto?
Beautiful. Done.
We're going to go look at the big man himself. We're going to go look at Jupiter, Zeus. He's the big guy.
And I'm going to go ahead and switch our view back as well. So sorry for this transition.
I see somebody say Alpha Centauri. Yeah, there are a lot of things that go to Alpha Centauri. Alpha Centauri and the other stars near it are the closest stars to our solar system. They're about 4.5 light years away. They're our sort of closest neighbors. And one of them is a similar star to the sun, Alpha Centauri. Others are not visible to us in our eyes. Explain dark matter. That's a good question. If I could do that, I definitely would not be working at the museum. I love the museum, but if I could explain dark matter, I know a lot of universities would be trying to hire me right away.
I'll take that at the end. I can explain it a little bit.
Yeah, dark matter, we know it's matter because it affects gravity. We can't see it. That's about the best I can give you. You can see here on Jupiter on the visual there, it's a great red spot. And that is a really classic example of how good astronomers are at naming things. They're like, it's big, it's red, it's a spot. What should we call it? You can also see too that Jupiter is really stripy, and it's got these areas, these stripes we call bands and zones. And these are basically cloud tops. Jupiter doesn't have any land, it's a gas giant. And the white sections are higher than the red sections, which are lower. And the difference is tens of thousands of feet. If you're flying above one of the red bands on Jupiter and you look out the window, you know, just like if you fly 30,000 feet here on Earth, well, and not a lot of flying going on now, but you know what I mean. And you look out the window, you wouldn't even be able to see the tops of the cloud tops in the zones next to you because the height difference between those bands and zones is tens of thousands of feet. And the Voyager spacecraft did study Jupiter. It was one of the first objects to fly by and study Jupiter, and they're still out there. They're still working. The Voyager spacecraft at this point, I think, are several light hours away from Earth. That means it takes light from the sun several hours to reach them. Since light goes 1 foot in 1 billionth of a second, that means they're billions and billions and billions of miles. They're really far away. They are still working. They'll keep working, the Voyager spacecraft, and they'll keep talking to us, but we won't be able to understand them in about 10 years. And that's because as they get further away, their radio waves get more spread out. Right now, we have a network of satellites in space around the Earth that capture these huge waves and redirect them back down to the ground so we can understand them. But in about 10 years, they'll be so far away that even if they're still broadcasting to us, that network will not be able to capture that huge radio wave. So got about 10 more years with the Voyager spacecraft.
Before we move on from Jupiter, I do see a great question in the Q&A with a constellation and mythology connection. Tell us a little bit about why, this is maybe a little bit of a leading question. I see what you're getting at here. Tell us why NASA named the spacecraft that watches Jupiter Juno.
So Juno, or Hera, is Jupiter's wife, and in a lot of the stories you heard, she's not too happy about him being the world's most notorious philanderer. And so what the Juno spacecraft can do is it has radar technologies that allow it to peer through Jupiter's clouds. And there's actually a story in mythology where Jupiter was getting a little wild with some friends, and he made it nice and cloudy so that he could hide from Hera, from Juno, but Juno was able to peer through those clouds. So that's why the Juno spacecraft ended up getting its name. The 4 biggest moons of Jupiter are all named for people that he slept with. Io, Europa, Callisto, and Ganymede. Callisto and Europa were in 2 of our stories. And so he's been hanging out with them for millions of years, and his wife just showed up, so watch out. And actually, one of the things we're hoping the Juno spacecraft can do is tell us more about what the internal systems of Jupiter are like. And what we have determined is that the atmosphere, the thick part of the atmosphere of Jupiter is about 1,890 miles. Here on Earth, that thick part of the atmosphere is only between 7 and 10 miles, depending on where you are on the Earth. So that's a really thick atmosphere. And then once you get down to the bottom of that, we think it's a pressure of about 100,000 times that of sea level. And so deep down in Jupiter, there's hydrogen and helium still. That's why we call it a gas giant, because hydrogen and helium are gases on the periodic table. But that gas is held together in a liquid form. Now, it's not like liquid in a glass that you could scoop up and swirl around. It's under so much pressure that it would act like the thickest of tars, but it is still a liquid. Some great questions. Some great questions.
Shall we move on, given the time?
Yeah, let's move on to Saturn.
All right.
Perhaps while we fly to Saturn, you can answer a couple of quick questions about gas giants in general. I'm seeing a lot of questions about, do gas giants have solid cores? How do they hold a spherical shape if they're not made of solid matter? How does that work?
Yeah, so we don't know what the cores of gas giants are like. One of the things we do know about gas giants is they have really strong magnetic fields. Jupiter's magnetic field is actually so strong that it speeds up dangerous particles from the sun and makes a lot of radiation. So when Juno studies Jupiter, it has to fly it in this big oval. It only gets close to Jupiter every once in a while because that radiation can fry its electric equipment. So we don't know if they have iron nickel cores like the Earth does. We don't know. That's one of the reasons we're studying them to find out. And then the reason they don't dissipate out into space is the same reason that the Earth's atmosphere doesn't fly out into space, and that's because of gravity. And in the case of these big planets, Jupiter, twice as big as all the other planets combined, it has a lot of gravity. If you wanted to know how much you would weigh on Jupiter, put your weight into a calculator, multiply it by what, 2.6 something, Naomi?
Yes.
And yeah, I would be, I'd be like almost 500 pounds. I'll let you do the math in reverse. So here we are at Saturn. Saturn is also a gas giant made mostly out of hydrogen and helium, just like Jupiter is. And Saturn is probably most famous for those rings right there. That's why you know God loves Saturn, because he put a ring on it. Saturn's rings are actually really confusing when they were first seen. You can't see Saturn's rings with your eyeballs. You can see Saturn with your eyes, but you can't see the rings. And the first telescopes, which were invented back in the 1600s, people were able to see the rings. They had no idea what was going on. They were like, it's a planet with ears. Well, sometimes it looks like a cocktail olive. What's going on with this planet? And the rings themselves, if you want to zoom in on them, Naomi, are actually pretty cool. They're really wide. The rings are really wide. They're about 67,000 miles from the inner edge to the outer edge, but they're also really thin. They're only about 50 to 30 feet thick from top to bottom.
And can you tell us a little bit about why that is?
What? Go ahead.
We had a question about why that is.
Why is that? That's because it's something called the conservation of angular momentum. Did you hear all that science that just fell out of my mouth? So these rings probably started out as more of a cloud around Saturn, and as they flew around Saturn, they might have bumped into each other. But even though they bump into each other and change direction, they don't lose any of their momentum. And then the gravitational forces of Saturn and its moons are also acting on them, and so that is changing their direction and their speed, but it doesn't change their momentum. Their momentum is conserved, and that has the byproduct of sort of flattening them out. This same thing happens when you watch somebody make pizza dough. They'll throw the pizza dough in the air, and as it spins in the air, it will flatten out. It also happens when you watch a figure skater. When a figure skater is spinning and they pull their arms in, their speed increases, but they pull their arms in, they take up less space, but their momentum is conserved, so they increase their speed. So the rings are made of solid matter. The rings are made of ice, just like the ice I have right here. Well, what's left of it. It's been sitting here for a while. Just like the ice that you put in a drink to make it cold. Water ice. And there's a lot of it out there. If we collected all the material in the rings and put them together, we would have something that would be larger than the Earth's moon. But most of the particulates are smaller than the size of a quarter. So if you ever run out of ice at your next, I mean, it's going to be a while before we can have get-togethers, but once all this is over and you have a big celebration, you need ice, you can just pop over to Saturn and get some. It's got plenty. It's going to take you 5 years to get there. So
way to social distance. Head to Saturn.
That's right. Head to Saturn for your ice. The ultimate social distancing. Ultimate social distancing. The rings have little gaps in them because there are moons in the rings and things like that tug on the rings. Saturn's tugging on them one way, the moons are tugging the other way, and that forms these little gaps.
All right, I think our next destination was Titan. Thankfully, just a hop, skip, and a jump from where we're at now.
I see a question here too in the Q&A that says, are the rings of Saturn constantly expanding? No, the rings of Saturn are actually falling into Saturn. When we when the Cassini spacecraft, which was studying Saturn, ended its mission, it flew between the rings and Saturn, and eventually we crashed it into Saturn so it could send us some last really cool data. And as it was passing through the rings and Saturn, the rings are crashed. They're falling into Saturn at a rate of about 40,000 metric tons of material falls down into Saturn every single day. That seems like a lot to us, but when you consider about how much stuff the rings are made out of, that's really not that fast. In a couple 100,000 years, they could be gone, but for now, we get the view of these beautiful, beautiful rings. Now we're flying off to Titan, and Titan is actually a really famous celestial body because Titan is where Thanos is from. Titan supported a thriving civilization at one point, and then they had experienced some serious collapse, and so Thanos took this really juvenile philosophy about resources and decided to unite the various stones in the glove and snap half of the universe out of existence. So this is the site of where all that happened. I'm just kidding. Titan is the second largest moon in the solar system. It is bigger than the planet Mercury. It is made mostly of water, ice, and when we look at it, we can see these dark patches. And those are actually lakes. Titan, unlike most moons, has an atmosphere. Its atmosphere is about 3 times thicker than the Earth's, but like the Earth's atmosphere, it's made of mostly nitrogen. It's really cold here, so you can't go to the beach. You know, no social distancing beach times here, because the surface temperature is about negative 280 degrees below 0 Fahrenheit. But if you could swim in the lakes, which are filled with liquid methane, by the way, liquid natural gas, you could there's less gravity there, and you could strap some little fins on and you could flip around like a dolphin in the lakes there, because there's less different density to the methane and less gravity. So the largest lake on Titan is called Kraken Mare, like release the Kraken. And it's pretty big. It's almost the size of the Caspian Sea. Titan is also orange because of these things we call hydrocarbons. Methane is the simplest hydrocarbon, which is hydrocarbons, things made out of hydrogen and carbon. Methane is CH4. Ultraviolet light from the sun can create chemical reactions. If you ever got a sunburn, you know that's true. And the ultraviolet light from the sun can actually knock some of the hydrogen off the carbon, and then they recombine into different forms like C2H6, which is ethane. You can have octane and things like that. So Titan's a really interesting moon. One of the things about Titan is that it could teach us about how, wait, I see a question here. Why did the Star Child in 2001 tell the astronauts to leave Europa alone? That's a great question. That's because in that book series, this is a reference to 2001: A Space Odyssey, and they talk about this alien civilization creating life, and Europa is a moon of Jupiter that has a huge liquid water ocean on it, so it's presumed that these aliens create some life forms there. That really tickled me. Sorry, you really hit me in the fanboy right there. But we're gonna fly off to Pluto in the interest of time, coming down to the end of our time together.
See, I had this great segue of speaking of hydrocarbons, Kraken to Cthulhu. I mean, we can go all sorts of ways here. All right, so a couple of people in the questions asked about Pluto, planet or not, and I think I answered I have definite opinions on this. So,
do you want to take this away? I know you do have opinions on this.
I do, and part of it is because I had a research advisor at the University of Denver who voted for Pluto to be a dwarf planet, so this definition was a big deal for us. So the definition, as it stands currently, was done by the International Astronomical Union, who's in charge of naming everything in the universe, even though we're only on Earth.
According to them.
I know. Well, but here's the thing. They had this great definition. They spent years on. They threw it out, came up with a new definition that week of their conference, and the last 10% of the astronomers voted on it right before happy hour on Friday.
So you know nobody cared. Nobody had any irons in that fire. All they wanted was the drinks.
Exactly.
All they wanted was the drinks.
So what we've got is a planet has to orbit the sun. Pluto does that. None of our 4,000 exoplanets do, but it's fine. We're not bitter. It has to be round, which is really not that hard. You have to be about the size of the state of Texas to do that. Please don't tell the Texans. That's my only ask. And then finally, you have to clear your orbit. The problem with this definition is it had to be fixed in a footnote because Jupiter and Earth haven't cleared out our orbits. So we're technically not planets. That being said, there's lots of reasons Pluto deserves its own classification. There's really amazing small icy bodies on the outside of the solar system we found in the past 2 decades that made us ask questions about what is the structure of our solar system and how do we classify it. Semantics aside of whether it's a planet or a dwarf planet, I still think this is, no pun intended, the coolest object in our whole solar system. And I know. And it's something that really is at the forefront of planetary science now, making us rethink about what could a planet with water look like? What could an active planet look like? This certainly blew away every expectation we had.
I see a question here too that says, what does clear out your orbit mean? And that, I think according to the International Astronomical Union, means that you're the only thing really in your orbit of a significant size.
It means
the reason that that doesn't count for Jupiter is because Jupiter shares its orbit with a bunch of asteroids we call the Greek and the Trojan asteroids. And that's also true for the Earth. The Earth will have significantly sized asteroids and things like that move through its orbit as well. And one of the things we think about in clearing our orbit with Pluto is, and I saw this in the chat earlier, somebody talked about some of the other dwarf planets we found like Umana and Makemake. And these were dwarf planets. This was actually one of the big reasons we started to think differently about Pluto. So this picture of Pluto is taken by the New Horizons spacecraft in 2015. And this is a great picture. Before this, the best pictures we could get of Pluto were these like fuzzy pictures with some patches of light and dark. And it was really hard for us to like explore this outer edge of the solar system. I mean, Pluto was discovered in 1930 in April by an astronomer named Clyde Tombaugh in Arizona. So I'm coming back to you, Arizona. Good for you. The Percival Lowell Observatory in Arizona. You guys did it. You found Pluto. And the Lowell Observatory found Pluto, and the way they did it is they actually took a picture of the night sky using a telescope there at the observatory, and Clyde Tombaugh looked at hundreds of these pictures. He looked at these pictures night after night after night after night to see if anything moved. That's how he found Pluto. It was a really like needle in a haystack sort of discovery. With our modern technologies, we are starting to understand that Pluto is actually on the inner edge of a sort of second asteroid belt in our solar system, which is called the Kuiper Belt. And it's filled with icy chunks of stuff. And we found these other Pluto-like objects out there, like these other dwarf planets, Umana and Makemake. Now, we haven't sent a spacecraft to these other dwarf planets, so right now the best pictures we get are these bright and dark, sort of fuzzy images, and we do this thing, it's called albedo mapping, where we look at what parts of it are reflective and what parts of it aren't. And that is how we try to predict what's on the surface. We did the same thing with Pluto, and boy, were we way off. We thought Pluto was going to be covered in craters like our moon, that its surface wasn't going to be active. But actually, its surface is active. It's got this big heart-shaped feature on it called Sputnik Planum. And that actually affects, it gives Pluto an atmosphere. That big plane, as it gets bombarded with sunlight, actually has frozen nitrogen fly off of it and form a little very thin nitrogen atmosphere on Pluto. And so the things we're learning about Pluto right now, regardless of whether we call it a planet or not, we're learning things about Pluto that we can then use and apply to these other new dwarf planets. The tricky thing would have become if we find 100 of these dwarf planets, then we'd have 108 planets in our solar system, and 100 of them would be really similar and 8 of them would be really different. So that's another reason behind that.
So we're running out of time. So let's go ahead and do our traditional zoom out ending for Great Space Escape, especially since we've had some requests to look at the Milky Way and see where we are.
This is the blow your mind part of the program.
And I'm going to turn on all of our constellations to give us some context as we zoom out here.
You can see Hercules right in front of us right there.
Yet another great hunter.
And Corona Borealis right next to him, that U-shaped constellation, but we've all got enough corona in our lives. I don't think we need to, we'll just leave Corona Borealis up there. Now, as we zoom away, you can see these stars are moving because they look next to each other to us, but they're actually really far apart, really far apart. And the way we map out the Milky Way is actually the same way that a weather person maps out a storm. They use radar, the Doppler radar. You see it like action news with Doppler radar. See how that storm is moving. So they beam radar into the storm, and they can tell by the way the things bounce back using the Doppler effect if the storm is moving toward them or away from them, spinning or what have you. And we do the same thing with light here for the Milky Way. So when light is moving toward us, we call it blue shifted. And when it's moving away from us, we call it red shifted. And using radio telescopes, we can actually detect the Milky Way. And so this is a real map. This isn't just some artist who said, oh, this is what I think it looks like. This is a real mapping of the Milky Way that we've done using that same Doppler effect, similar to the way a weather person maps a storm. The dark spots that you see are not where there's nothing. It's actually where there's so much stuff we can't see through it. The Milky Way is full of stuff. And if my shoe were the size of the solar system from one end to the other, that's a couple billion miles, about 9 billion miles, then the Milky Way would be the size of the continent of Asia. That's how big the Milky Way is. Really
Someone asked about how we can see the Milky Way when we're inside it. So those red lines that you're seeing are the constellations. They all center back on Earth. So when you see the Milky Way in the night sky, if you're looking at it during winter, which is where we are now, you're actually looking out to the edge. And I'm pointing, like you can see where I'm pointing. I apologize. You're looking out to the edge. And so you're seeing that beautiful spiral arm on the outside of the Milky Way looking out. And in summer, we actually look towards the center. And so what we're seeing is basically like a little cross section of this forest of stars. And we look right towards the center. And so you're seeing a bunch of stars in that thin sliver that we're able to see without being able to do this cool thing like we can do in UniView and zoom out.
Yeah, just like a submarine can see, you know, it's in the ocean and it can see the ocean around it, right? It doesn't have to be out of the ocean to see where it is. It can use that radar to find its location. It's the same thing with us. We don't have to leave the Milky Way in order to map it out. I saw a question in the Q&A about whether or not we are falling into the middle of the Milky Way. Nope, we are going around in an orbit. It takes about 240 million years for us to complete one orbit. But here we are zooming out, and these dots you see here, these are not stars, these are all other galaxies. The different colors are because they orbit around each other in big groupings we call clusters and superclusters. And this is that real blow your mind moment. Every one of these dots is a galaxy that is filled with potentially hundreds of billions of stars, trillions of planets. Those gaps that you see there are not because there's nothing there, it's because the center of the Milky Way is really, really bright. And so it's hard for us to see through it, so we don't get as much information. And you notice that there's a lot of dots on one side, not as many on the other. That's not because there's not as much stuff there, it's because most of our telescopes are in the northern hemisphere. And then as we zoom out, right here at the end, you can see these weird patches of color with like red and yellow and green and blue. And that's what we call the cosmic microwave background radiation. That's actually the afterglow of the Big Bang. That is the moment when the universe, after the Big Bang kind of settled down and became transparent, and the afterglow of that rapid expansion is that cosmic microwave background radiation. It comes from all directions all the time. It was first discovered it was first predicted in the 1940s. It was discovered in the 1960s. And now our radios are so powerful that you can hear this in your car. If you tune between the radio stations and hear static, about 3% of that static is the beginning of the universe. Every time I fly out here and look at all these galaxies and think about how big, because this is just a fraction of a fraction of a fraction of the universe, it gives me the same feeling that I feel when I've been going out on these social distancing days and walking the dogs and looking up in the night sky and just, you know, remembering that the sky, the universe, it's around all of us, you know. Sometimes I feel so trapped in my condo. Sometimes I feel, you know, so distant from so many other people, but then I can look up at these distant things and be reminded that we can all look up at those distant things and that they connect us, even though they're so far away.
Absolutely. With that, it is 9:00 p.m. and I think I feel really inspired by all of this to go outside The weather's starting to change, so maybe I'll go put my coat on, go outside and look up and see if I can see anything or if those clouds have moved in. I invite you all to go out and do the same, and maybe we can all have a little moment of human connection, even though we can't be physically with one another. And to that end, I do want to say a giant thank you to all of you for joining us this evening via Zoom. We are so grateful that this incredible platform allows us to connect with you all and share the wonders of the universe with you, even though we can't be in the same space right now. And museum members, we are so incredibly grateful for your support, for you continuing to join us. Again, this program was provided live exclusively for you because we are just so grateful that we have all of you throughout all of this, and we cannot wait to the day that we can welcome you back to the museum. But for now, we'll continue to say hi and teach you things online. Thanks for tuning in, everybody. Go outside and look up at the sky. A huge thank you to Jose and to Naomi. We hope you learned some incredible things, and we'll see you next time. Bye, everybody.
Bye, everyone.
Bye.